Okay, so right now we're going to look at graphing the solution to the following system of inequalities. And that's not really too different than any of the previous examples, except for now, for this problem, you get two inequalities for the price of one. So if you are looking for the solution to the system, what we're looking for is the intersection of all of the shadings. So we're just going to have to make sure that when we graph each inequality, I like to graph the boundary curve first, and then I figure out the shading, and then I move on to the next inequality. So starting off with this particular inequality that I've boxed in green, I'm going to look at replacing the inequality symbol with an equal sign so I can understand what the boundary curve looks like. And our past experience from conic sections, we noticed that only the y variable is squared. So only one of them is squared, which means we've got ourselves a parabola. And since it's solved for x, we actually have ourselves a horizontal parabola. So you'll notice the way that this equation is set up, it doesn't have anything to do with a 4 or a multiple of 4. We've seen that from using our equations from the conic sections. This is more something that we have in standard form. So if you recall with me, this particular equation, just so that we can compare everything, we have x equals a times y minus k squared plus h. So that's kind of the generic form, or I say standard form. And from that nice form, we're able to tell what the vertex is. In this case, it's h comma k. Now, another thing we pay attention to is we like to look at which way the parabola is opening up towards. So that's always done by the a term, or the coefficient of the squared term. And if you look at our particular parabola, the coefficient of the squared term is just a positive 1. So that's going to give us a hint that we are opening up towards the positive side. So that's opening up to the right. So that's already, we have a lot of information about this parabola. Now, if I'm going to graph it, I'm going to look at understanding what the vertex is. So in our case, if we're looking at the h, it is the constant. So that's 1. And if you notice, if you're looking at the squared term, we do not see anything added or subtracted to the y value. So that's assumed that it's 0. So that's going to give us the y value of the vertex. So 1 comma 0. And the best thing I can do for myself is plot it right here. So 1 comma 0. And understanding with the vertex, if you know it's a horizontal parabola, your axis of symmetry should cross directly through the vertex. So sometimes I either picture it there, I imagine it there, or sometimes I might even draw it just for reference if I'm finding points for my parabola. So I'll do that for now. Now, as far as accuracy is concerned, at this stage, what I'd probably do is I would pick a XY chart to help me out with finding more points on the parabola. I already know the vertex is 1 comma 0. So if we look at our particular equation, we notice that it's solved for x. So it's probably nicer to choose values of y. Because it's already easier to solve. You just compute the expression that you get as opposed to keep solving a few different equations. But it's up to you. I know you have a lot of algebra skills. You can utilize them however you'd like. But I just kind of go with the y values. And if I already had a y value of 0, maybe the next natural number I might pick would be 1. So I'll kind of go with that. If I chose y equals 1, I plug it directly into my parabola. So x equals 1 squared plus 1. So that'll give us 1 plus 1, which is 2. So kind of notice if we're choosing values of y, we're replacing the x value with 2. So I can plot that right away, 2, 1. And here I will use symmetry to find the other point that's kind of corresponding to this. If we have 1 unit above the axis of symmetry in this case, we can plot another point right below, 1 unit below, and we found that by symmetry. So you could either name the ordered pair or not, it's up to you. So I know that like 2, -1 would be found by symmetry. So it's already kind of agreeing with the way the parabola is supposed to be opening up towards to the right. However, if we're given a grid, we want to have a little more accuracy. So I'm going to pick another point, another y value. And kind of natural for me, I might say, hey, what happens if y equals 2? You kind of see me plug this in, if y equals 2. And getting x equals 2 squared plus 1, which is 4 plus 1, which is 5. So 5, 2 will be another point on the parabola. So we can graph it. 1, 2, 3, 4, 5, and 2. And then again, if we want to use symmetry, what you can do for yourselves is just say, okay, well, it's 2 units above the axis of symmetry. So if I count 2 units below the axis of symmetry, 5, -2 is found by symmetry. So usually having these few points, I think it's 5 points on the parabola that are symmetric. This is pretty good for accuracy. Sometimes you may see me pick another point if I have a little more room to account for. You might say, what happens when y equals 3? Feel free to explore that, but for the purposes of this accuracy, we are good to go. So I'm going to connect my points. And remember, since I'm looking at an inequality, I have to look at the inequality symbol. And I'm going to notice that we have a greater than or equal to. The key being the equal to, the bar underneath the greater than symbol. So that gives me a heads up that I've got myself a solid curve that I'm going to have to graph. So I'm going to connect these points with a solid curve. And remember, it's a U shape, I think, to the side. We'll do the best we can. I'm a little off. I'll do a little more accuracy. There we go. Now, see, we have a nice graph by hand. If you were inclined to maybe use your TI to check the curve, I'll kind of show you that, just how you can incorporate the technology into this. So if I were using the TI for this, what do I have? X equals y squared plus 1, or I'll draw x is greater than y squared plus 1 so I can see that later. If I were using the TI, I would then have to solve this for y, just so I can check to see if my boundary curve is correct. So if you were solving for y, a little algebraic exercise, we can say, let's move the 1 over by subtracting 1 on both sides. So what does that leave me with? X minus 1 equals y squared. And a lot of times you're more comfortable with making the y square on the left, x minus 1 on the right. All I did was use a reflexive property. And if you're solving for y, what would happen is we'd have to take the square root of both sides. And so that would leave us with a y. Don't remember, well, don't forget, we also need the plus or minus symbol. So we have plus or minus square root of x minus 1. Now, if you're trying to graph this with your TI, in our TI, there's a couple ways to go. Some TIs will break this up or have you break this up into y1 equaling the positive version of square root of x minus 1 and y2 equaling the negative version of x minus 1. Or a little trick I'll show you. Depends on what operating your system that you do have. What we can do for ourselves if we don't want to have the plus or minus and we don't have to, how do you say, copy and paste? Like, well, we can't really copy and paste in our TI, unfortunately. You could just turn this all into y1. And the plus or minus symbol is actually used with set braces. So we'd have plus 1 with a comma minus 1. And that's indicating that we would be multiplying that by the square root of x minus. So that kind of accounts for the plus or minus symbol in this case. I'll kind of show you that. For purpose of trying to understand what the boundary curve looks like, we can go with this. So I'll kind of just switch over just so that you can see that we're accurate here. Let's switch over. And usually what I do is I use the y equals 2. And again, if I'm going to use the trick with the plus or minus, so I get everything in the same color, I would have to go find the braces. So that's where the parentheses are located above the number 8. So in order to access them, I'd have to press second parenthesis, left opening, or it opens up to the right. I'll press the 1. The comma key is located above the 7. Then I'm pressing the -1, so I'm negative. Make sure it's the negative key and not the minus key. 1. And I'm going to close the brace, so that's the other parenthesis, so second end parenthesis. So that's the plus or minus symbol. Now we're looking at the square root, so that's second x squared. And then we're going to type in our variable x minus 1. Press enter. And if you notice, if you want to graph it, you kind of see like, oh yeah, it does look pretty darn close to what we have. So I'll kind of flip back so I can show you. It is correct. It's opening up. Yeah. Take a look. And we feel pretty confident about this. So that's great for kind of verifying if you're feeling that your boundary curve, maybe you were confused a little bit. However, there's no need to if you are doing your best to pick ordered pairs and you're being accurate here, there's really no need to pull out your TI. So I'll get back to this a little bit more when we talk about shading. So like I said, I like to do these by hand, mainly because it takes a little time on the TI. You have to not only solve for Y, but on the TI, we would have to know what our shading looks like ahead of time. And if you're already figuring that out by hand, you know, why would you repeat your process on the TI? So I'll kind of give you more heads up about that in a second. So first thing, you guys want to figure out the shading. This is where we pick the test point. So if I'm looking at the test point, I can either shade on the outside of the parabola, maybe where the directrix would be, or I can shade on the inside of the parabola where the focus would be. So I'm going to try a test point. Maybe I'll pick 0, 0 because it's outside the parabola. One of my favorite points to pick. However, if your curve goes to 0, 0, you're going to have to pick something slightly different. So if I take this and I plug this in to x is greater than or equal to y squared plus 1, 0, 0, it's like a question, is 0 greater than 0 squared plus 1? So let's check it out. Simplify, 0 is at greater than 1. And if we look at that, that is false. So notice your test point was where kind of the directrix would be around, located, not necessarily here, but it's on the outside of the parabola. So if you get a false statement, then what happens with the shading is we should be looking at shading on the inside of the parabola. So I'll use vertical lines to help me understand this shading. Right here. Now I'd like to pull your attention back to using the TI. The TI does have an understanding of shading. However, you have to already know where the shading is going to be to tell the TI what to do. So I'll kind of show you this just for aesthetic purposes. But like I said, I really don't waste time with it unless I'm trying to maybe make a nice graphic to present this later. But I'll show you now while we're here. Here's the issue. Shading is not going to work well when we use this particular notation to deal with our parabola. For purposes of shading, here I would use maybe if I'm just looking for the boundary curve. I would probably use this if I'm trying to understand shading or just trying to draw myself a picture. So if we're looking at the y1 equals square root of x minus 1. This is the top half of the parabola. And if we're looking at the y2, negative square root of x minus 1, this is the bottom half. And so let's go back to our TI, kind of switch over for you. And I'll go to my y equals and erase this out. And what I'm looking for myself, I'm just going to look at the square root of x minus 1. And then the negative. Be careful, you're using the negative key. That's right by the enter symbol, not the minus. If it gives you an error, you know, just switch it around. If I have a double negative, I want to be careful there. Okay, we're going to graph this. As you see, top half, bottom half. Now, if you want to get your TI to kind of understand the shading, what happens is you have to do this curve by curve. So if I look at the top half of my particular parabola, I know because I've done a test point that the shading should be below. So in order to kind of demonstrate this with your TI, go back to the function editor, that's y equal, and you can go scroll, use your left arrow key to scroll all the way over to the left side. Now, I have a TI-84C for this particular demonstration. If you have a TI-83 or just a TI-84, all you have to do is keep pressing enter until you're trying to understand, you're supposed to get a triangle. And I'll show you what I'm looking for. So if I press enter, you won't have this menu if you have kind of a little older operating system, but the line style is what we're trying to understand. So if we look at this, if you are using older operating system, you just keep pressing enter until you see your option that you need. If we have kind of the TI-84C, we can press the left and right arrow key. So you see that there's two options for triangles, and that is indicating shading. So let me go back one more time. I have my line, my original line. If I'm looking at this upper triangle, that's telling the TI to shade above the curve that I've just drawn. Now remember, we've just decided already that the shading should be inside the parabola, so we should be using the lower triangle. So I'm going to select that. And if you're just using enter to select, all you have to do, you don't have to press anything. Once you see that lower triangle, you just move the right arrow key over back to your function and then press enter. If we have a TI-84C, we just have to press OK. Okay, so let me graph it to kind of show you how cool it is. Let me go all the way over to the, there we go, press enter. Let me graph it and kind of show you how pretty it is. So right away, it has the shading below. So that's kind of pretty. It's very satisfying to the eye. Like, oh, no, the TI does that. However, we also understand that it's only shading directly below the blue curve. It's not even accounting for the red curve. So if you're trying to understand the shading, it is the intersection of these two. So if you want to understand, I need to shade on the inside of the parabola, the red curve, I'm going to have to shade above it to get this particular shading to work. So we can go back to the y equals. And again, we'll scroll all the way over to the left using the left arrow key. And once you have the left side highlighted, you press enter. And this time we would be looking for shading above. So we have the upper triangle. Now you just keep pressing enter if you have a little older operating system, but we're going to press OK. I'm going to scroll back over to the right, press enter, and here we're going to see some beauty right there. That's so nice. So as you can kind of see, you're like, well, the TI doesn't really demonstrate the shading, except for the fact is you do see a clear overlap, and that is really consistent with what we actually have decided with our test points. Let me switch back for you right here. You kind of see like, oh yeah, we already knew we're supposed to shade on the inside. So maybe if you were trying to copy and paste this for a report, you might kind of use a TI. But like I said, I'm not, I think you spend a lot more time trying to deal with that than just doing things by hand. So notice we're not quite done. We've only done the shading for one of the inequalities. So we're going to go and we're going to do the same thing for the other inequality. So I'm going to take this off to the right, and it is replacing this inequality symbol with an equal sign. I have x equals 7 minus y squared. And again, I'm recognizing right away, I only see one of the variables being squared. Right away, that's telling me I do have a horizontal parabola. And it's not quite in the format where we were looking for directrix and focus. It is in this nice standard form that we are used to. So we already know where we can find the vertex. It's the constant, which is in our case 7. And there's no number that's being added or subtracted from the y, so that's assumed that it's a 0. So I have my vertex at 7, 0. The other thing I'll point out for myself is that I do have a negative coefficient of the y square. So just a little heads up, it opens up to the left. So when I plot my vertex, 7, 0 on the same axes, I just count 1, 2, 3, 4. And let me see if I can mark the grids for you. So 1, 2, 3, 4, 5, 6, and 7. So I have 7, 0. I'll count one more time because my eyes are kind of tricking me. 1, 2, 3, 4, 5, 6, 7. Perfect. So I got my vertex right here. Now I do know it's opening up to the left. So what I'm just going to do is I'll just take another swing at the XY chart, perhaps make a little more of a vertical line. And we already have the vertex taken care of. And so again, since it's solved for X, I'll just kind of choose values for Y. A little quicker for me. So I'm kind of go along the same route. I'm not too creative here. If I have Y equals 0, might as well choose something like Y equals 1. And so if we were to do that for ourselves, we have X equals 7 minus 1 squared. Simplify 7 minus 1, we have 6. So now we have an ordered pair. X equals 6, Y equals 1. We can plot that right away. So 1, 2, 3, 4, 5, 6, 1. It's making sense to where the parabola is opening up to the left. And we can use symmetry to figure out if it's 1 unit above the axis of symmetry. We know that another point lies 1 unit below. So 6, negative 1 is found by symmetry. So we want a few more points for accuracy. We do have a lot of space on the left side. We'll go with Y equals 2. So that's X equals 7 minus 2 squared. So 7 minus 4, end up having a 3. So 3, 2 for X, 3X, Y is 2. So 1, 2, 3, and 2. And then by symmetry, we notice it's 2 units above the axis of symmetry. So count 2 units below, and we've got our other points. So 3, negative 2 by symmetry. And for purposes of kind of making this a really, really nice graph, I see a lot of room on the left side, a lot of empty space. I'm going to pick another Y value. So perhaps you'll see me pick Y equals 3. A little further off to the side. So X is equal to 7 minus 3 squared, which will be 7 minus 9, which is negative 2. So negative 2, 3 this time. Let's go back and plot that. So negative 2, 3 is located over here. And by symmetry, once again, if you're 3 units above, 3 units below will also have a point on the parabola. So that's a lot of accuracy. If you want to pick Y equals 4, all power to you. Next thing we want to decide for ourselves is, should we have a solid or dashed curve? So go back and double check. And you notice right away, less than or equal to, we are using a solid curve when we are doing our sketching, our graphing. So we'll do our best, trying to make ourselves a U shape. I'm a little shaky when I have to go out this way. You guys don't know already, I'm left-handed. Sometimes that causes issues on the computer. So it's a pretty accurate sketch. And again, if you're interested in trying to understand, hey, is this correct? Am I really sure about this? You could go and check with your TI. And you could say, okay, let's take a little more time. We have, let me double check. I have x is less than or equal to 7 minus y squared. And if I use the boundary curve, x equals 7 minus y squared, if I solve it for y, we can take our time on our TI to understand what we're dealing with. What do we have? Like x, we subtract 7 on both sides, we would have x minus 7 equals a negative y squared. Now, if I were to switch the sides, I'd like to move y squared over to the left. I'd add y squared to both sides. And feel free to use more steps if you'd like. If I move the x minus 7 over to the right-hand side, I'd be subtracting off x and adding 7. You could also say negative x plus 7, no big deal. So again, if you're trying to isolate the y, we take the square root of both sides, we'd have y equals, making sure not to forget the idea of the plus or minus sign. So we have y equals plus or minus the square root of 7 minus x. So again, you could go back and using this notation if you're only checking what the boundary curve is. But since we might be addressing what the shading might look like, this would kind of lead us to say, all right, why don't we take this? And we already have y1 and y2 enter, so we'll have y3 equal the positive version of square root of 7 minus x, and y4 equal the negative version of 7 minus, square root of 7 minus x. And now if you're understanding how this works, playing with parabolas already, we again have the top half with the positive, and then we now have the bottom half with the negative. So let's just verify. Remember, we're just trying to see, yeah, is it opening up to the left? Does it look about right according to our other curve? We're going to switch over. And again, you don't have to do this. I'm just doing this for purposes of just exploring using our TI. I'll press y equals. And again, if I'm looking at y3, I have the positive version of square root of 7 minus x. And y4, I have that negative version of the square root of 7 minus x. Be careful, sometimes the calculator is sensitive. Now, all I'm doing right now is graphing it just to see the curve. And when you kind of look at it, you're like, yeah, I feel pretty good about this. Let's go back really quick. You can kind of show that. Does it look like what we just graphed in blue? And yeah. Of course, ours isn't as, how do you say, pretty, but I think we're doing a pretty good job. Now, my friends, if you're trying to understand, I need to understand the shading of this particular parabola, we can go back and use test points. So I'll do that. I'll do that by hand, and then I'll kind of show you what we're looking at on the TI. So here we go. I know I'm kind of using everything off to the side. Let me write out. I'm looking at x. X is less than or equal to 7 minus y squared. So if I were to test, let me go back. There's a lot of paper we're using. I probably should have left a little more room, but I'm kind of showing two concepts at once. So double check, if I were to ask what happens if I shade on the inside, that again is a nice point. I can pick 0, 0. I'll go back, test 0, 0. And if we were to plug that in, 0 less than or equal to 7 minus 0 squared. So is 0 less than or equal to 7? Yeah, we got ourselves a true statement. So if we have ourselves a true statement, we shade the region containing the test point. So you could kind of see how the shading is going. I'll kind of shade the maybe the perpendicular direction, maybe horizontal lines. It's also pretty, but we're getting the idea. So we know we're shading the inside of this particular parabola. So one more thing, if we're trying to determine what the solution is, well, the solution is the intersection of the two shadings. So if you kind of are looking at this, which place did we color twice with the orange and the pink? I'm seeing yellow region. And so that, my friends, if you're not doing any erasing, you would definitely want to indicate that you have your solution region. If you don't point to your solution region and the teacher is looking for work, all you've done is graph the union of the two graphs. So I definitely try to shade the solution region in darker, or I point to where it's located. So that is the solution to the following system of inequalities. Usually what you see if you were checking answers in the back of the textbook is they don't show you that you're actually, the reason why we are picking the solution region is because you're taking the overlap. What they end up doing, let me see if I can show you, is that they actually erase all of the shading in terms of from the previous graphs. I'll do my best. And you'll only see, you will only see the curves that are being graphed. Let me see if I can draw the other curve back in there. The best that I can. And generally what happens is they only show the shading is the actual solution of the inequality. And that is true. That's what we're looking for. So in our case, it kind of looks like an ellipse that's kind of being shaded. Maybe it's more of like an eye shape or maybe a football shape. But that is how we find the solution to a system of inequalities. So like I said, if you're doing this strictly by hand, it's probably a lot more faster. It's a little nicer to keep track of, but I would like to show you just with the TI and demonstrate that, yeah, it does give you a nice picture as well. So one more thing. Again, if we're dealing with top half and bottom half, remember, if our parabola is facing this way, and the other one is opening up downwards, the top half would be having to be shaded downwards or below. So you would use the lower triangle. And the bottom half would have to be shaded above. So you'd have to use the upper triangle. So let's switch one more time. And all we do is we go in the function editor and we tell the TI what to do. So we just scroll all the way over to the left. My line style will be a lower triangle. I'll press OK. Move all over, press enter. Scroll all the way to the left one more time, press enter until you can figure out that you're using the upper triangle. Press OK, scroll all over, enter, graph. You kind of see, I always found this quite pleasing just to watch the TI do this. It's kind of something about it's really satisfying to me. Now it's great if you have different colors to kind of see where the overlap of all the regions are. But sometimes with my older operating system, like if I'm using a TI-83, it might get quite messy and it kind of looks like everything is colored in. So like I said, that is just another reason to kind of have your method by hand down for this. So let me copy it over and just kind of show you while we're here, see if I can copy it on top of one of these. Paste it. Here we go. I just kind of want to show you like, yeah, it's nice. Side by side. You can kind of see like, oh yeah, why don't we look at that? Now, the only thing is you kind of have to say, well, how do I figure out what the solution is? Again, my best way might be hard to see, but we do see that it's kind of like a football or an elliptical shape. That is actually what the solution is. So our TI does demonstrate shading, but like I said, you kind of pick what works best for you to help you out. I prefer just determining the shading using test points. I think that's a lot faster. Feel free also to play with the Inequals app. If you have that, sometimes that gives you maybe a little faster way to find the solution without having to deal with all the intersections. But again, you still have to know what you're looking for. So feel free to read the text if you want a little more detail about that. But again, if your calculator doesn't have that, no worries. I think still faster to do it by hand. So I hope this helps. I kind of like these a lot. It's just kind of more artsy. I really like the pretty curves and the colors that we're using. So feel free to use a lot of colors to determine this. Please just keep practicing them. A lot of times these problems are really good to practice recognizing conic sections and such. So having said that, I'll see you in the next example.